All right, grade 8. So last thing, revision on squares, cubes, and roots. Again, I say if you've used a different method in primary school that is more comfortable for you, then please go with that as long as you show you're working out. We are fine with any method that you have been taught. All right, so for the first one, it says 0, 3 squared. That means it's 0, 3 times 0, 3. That's what squared means. Then just look at the number decimals. 3 times 3 is 9. And because we're multiplying, we need to build up decimals. So we need 2 decimals after the comma. So we've only got 9 now, so we've got to fill in a 0. So the answer is 0, 0, 9. For number 2, we have negative 0, 0, 4 times negative 0, 0, 4 times negative 0, 0, 4, because we are working with cubing. So let's look at the sign first. We have a negative times a negative, which would give us a positive. But then that positive is going to be multiplied by a negative, so our final answer is a negative. Now, the thing with cubing or any odd power that we're raising to, if you are taking an odd power with a negative number, you are always going to get a negative answer. If you are squaring or raising to the power 4 or 6 or 8, any even power, then you're always going to get a positive answer. All right, so then now we're going to look at our numbers. 4, 4, 4. So you actually just have to cube 4 here. So 4 cubed, so 4 times 4 is 16, and 16 times 4 is going to give us 64. So the cube, if we cube 4, we get 64. But now we've got to be careful. We have how many decimals in our original? We've got 1, 2, 3, 4, 5, 6. So we've got to make sure we have 6 decimals after the comma. I just want to make my negative there a little bit smaller. Right. So if we have our comma, we're going to have 1, 2, 3, 4, 5, 6, and then a 0 before the comma. Now, I know it looks like a daunting or intimidating number, but it's perfectly correct. For number 3, we've got to be careful with number 3. Don't forget your BODMAS. So before we square, we've got to sort out what's happening inside the bracket. So if you need to on the side, do a little working out, 0, 2 plus 1, 3. But then you're going to work with 2 plus 3 is 5. Keep your decimal in the same place for addition. 0 plus 1 is 1. So we have 1, 5 all squared. So that means 1, 5 times 1, 5. So now again, we're ignoring the decimal. We're just looking at the numbers. So imagine this was actually 15 times 15. Or 15 squared is 225. So 15 times 15 is the same as 1.5 times 1.5, but without the decimal. So we have 2.25. So why have I said 2.25? Because I had a decimal there. So when we multiply, we build up our decimals. Okay, so then for number 4, 4 is looking at the roots. Okay, so we have the root of 0, 49. So it's a square root because it doesn't have a number there, so it's got that invisible 2. Plus the square root of 1, 21. Now, hopefully under there it looks a little bit familiar. If you know your perfect squares, you see a 49 and you see a 121. So let's look at these individually. And again, when it comes to square rooting or division or anything of the like, you could change it to a common fraction. So I'll do it both ways and then show you the fraction way in a second. All right, so you've got to ask yourself, what would have been, or what is the square root of 49? So we know the square root of 49 is 7, right? So ask yourself, what would have been squared to get you 2 decimals if it had a 7 in it. So is it 0,07 or is it 0,7? So let's think. 0,07 times 0,07. Our 7s would make 49, but then I'd have to have 4 decimal places. If I had 0,7 times 0,7, 7 times 7 is 49, but I'd only have 2 decimal places. So if you've got 2 decimal places under the square root, it means it came from a single decimal place that was squared. So that's why the square root of 0,49 is 0,7, because you could square it again and get back to the answer under the square root. Okay. So then if we have a look at, so we're going to add that to the square root of 1,21. So now I'm going to throw in using the common fraction, just to show you how you could have done the first one. So 1,21 is the same as 121 over 100, because there's your units, your tenths, your hundredths position. Don't forget your square root. So what's the square root of 121? It's 11, and the square root of 100 is 10. So 0,7 plus 11 divided by 10 is the same as 1,1, because we need to land in our tenths place. So then you have 0,7 plus 1,1 is 1,8. All right, so if you need it on the side, you keep your decimal in the same place. 1 plus 7 is 8. 1 plus 0 is 1. Okay, so alternatively, if we had done it with the fraction for the first one, we could have had it as 49 over 100, because we're in our hundredths position, and that would have been square root of 49 is 7, square root of 100 is 10, and that is still 0,7. So whatever you feel most comfortable working with, you're welcome to do so. All right. Then looking at number 5. Number 5 is a cube root. So the cube root of, and then now there's first something we've got to do. These cubes, these square roots, all of these roots act as brackets. So we first got to work out what the answer is underneath the square root sign. So again, if you can see it easily, then you can just do it straight away. But if you need to, you can pile up underneath there if you want. So 6 plus 1 is 7. 2 plus 0 is 2, 0. Okay, so then we're actually looking for the cube root of 0,027. So I would encourage you to probably show that piece completely separately, just in the side. Okay, we don't need to see any sort of weird working out. You can do it on the side in rough. So let's go with the fraction method. So this is 27 over 1,000 being cube rooted, meaning they came from perfect cubes that were cubed to get you 27 over 1,000. So what's the cube root of 27? It is 3. Cube root of 1,000 is 10. 3 divided by 10 is 0,3, because we're in our tenths position. Alternatively, you could have said to yourself, well, what multiplies by itself to get 27 if we're cubing it? We multiply 3. But we end up with 3 decimal places from something that was cubed. It means we must have just had 0,3, because 0,3 times 0,3 times 0,3, 1, 2, 3 decimals make up for that 3 decimals in the original question. All right, so again, there are options for you. But just make sure that you always work with what's happening within a bracket or under a root sign first. For number 4, they were completely separate, so we can do them separately. And I suggest that you write out, when they show you squaring, you write out the square as what it means. Okay. Again, with the multiplying, you could have said this is 3 over 10 times 3 over 10. Top by top is 9. Bottom by bottom is 100. So you have to be in your 100th position. So units, tenths, hundredths. So you choose, you decide. All right, so then you can get on with your exercise 14.6, and then that is the end of this section, and so you can then also work on your revision exercise on page 175 of your textbooks. The answers to the textbook exercises are in the slides that are on the Google Classroom, and please ask your teachers if you need help with any of this work.